So what is interesting about this is that the light is being produced by a chemical reaction, but if you have an explosion you can have light. It's really hot. But this is not terribly hot. Just feel that. Is it hot? We'll just see if they're being honest. Is that hot? No. So it really is quite cold. Now, and you can see the other one's the same. I won't repeat asking people. Now, molecules are not like people, because you or I, if it's cold, start shivering really hard, and if it's hot and warm, like it has been the last few days, we just laze around and do nothing. Molecules move really fast when they're hot, and go really slowly when they're cold. So if this is a chemical reaction, we ought to be able to stop it by cooling it down. So in here, in these two containers, I've got liquid nitrogen, which is really cold. It's at minus 196 degrees centigrade. So let's see what happens if we try and cool one of these down. So I'll pour the liquid nitrogen into a beaker. You can see it has quite a nice... I like it.
Sir, you look like an evil scientist.
I am. Well, actually, I'm a green chemist, which is quite appropriate here. So, the nitrogen starts boiling. Nitrogen is colourless, you can't see it, but because it's cold, it cools the air, and the air contains water. So what you're seeing is essentially a small fog. And so, conveniently, this is on the string because I wouldn't want to cool my finger. We can lower it inside. Ooh, sounded fun. Now, there's another one here to compare. And you can see already the one inside is a bit dimmer than this one. I think we may crack the tube in the excitement. And you can see it's nearly gone out. Now, from this experiment, straight away, you can see that if you go to a fun fair or something and buy one of these and take it home and it's bedtime and you'd like to have it the next day, if you pop this in the freezer, it will slow down and the next morning you can warm it up, or the next evening, because there's no point having light stick during the day. So, can you see it's now more or less completely gone out? Do you agree? Yeah. Now, if making something going cold makes it go slower, then if we make it hotter, it should go faster. So, in here, in the other beaker, I've got some hot water. Sam boiled the kettle just before we started. So let's put this in the hot water and see what happens. And here again we've got our control. And you can see at the moment it's completely switched off. And as it warms up, we crack the tube open, which is quite exciting in itself. We may crack the beaker or both. So let's just let that warm up. I should say, the reason that people have these light sticks is not to go to fun fairs and so on.